All right, let's get started. Intermediate Algebra, Math 92, Unit 1, Lesson 0. So we want to talk about some math terminology. And when you use brackets, have you noticed in the textbook they'll have a bracket. Okay, so these are three types of parentheses, okay? You have the first one is most people know as parentheses. Some people call that the soft round brackets. This one right here is a hard bracket or a square bracket, however the terminology works. This one is set notation, okay? So when you see a problem in there, they'll have, if they have to put a double parenthesis, they're not going to use two of the curved ones. They're going to use a different kind. Okay, so if they're like something in there plus 3 close bracket plus something else, okay? So that's just different types of brackets. The absolute value bars, though, are straight. Okay, so inside you can have items inside there. Those are considered parentheses when you're working with orders of operations. Okay, you always work from the innermost parentheses out. Okay, so you work in here, that kind of thing, okay? Within parentheses, you have expressions. Right here it says it's a mathematical phrase that can contain ordinary numbers, variables like x or y, and operators like add and subtract. So an expression. This is a variable term, a constant term together that makes an expression. It doesn't have an equal sign, which would make it an equation. So if you have an expression, you can distribute. So the minus sign is considered a math operation, okay, subtraction. And all you can do with these is simplify them or evaluate them. Okay, when you have expressions, when you have equations, equation by definition are two expressions linked together with an equal sign. Okay, and then you solve an equation, but you simplify or evaluate an expression. Okay, so with orders of operations, most people remember the please excuse my dear Aunt Sally, and these are used to simplify expressions. Okay, so even if you have an equation, on each side you might have all kinds of stuff going on. This would be the expression part, and whatever's over here is an expression part, and together the whole thing's an equation. All right, so you would find wherever parentheses and do whatever's in the parentheses first if you can. Then you're going to find exponential notation, and that applies also to square roots. If you have something squared, if you have something cubed, you want to do that first. You also want to do any kind of square root first, process them after the parentheses, okay? And then you're going to multiply or divide as you come to them left to right. So if you have a division in the problem before a multiplication, you want to do the division first, okay? So it's multiply and or divide as you come to them left to right, and then you add and subtract anything that's left, okay? Sorry, let me clean all this up here. Okay, so for example, this is an expression that has some, there's no variables in it, it's just all constant terms or just numbers. This base 3 raised to the second power, that's an exponent. Okay, I don't see any parentheses, so I need to do that first. All right, and then go find any multiplication or division to do next. So this is 36 plus 12 minus 2. Okay, now I'm ready to add and subtract. All right, and this one here, same way. I want to process this exponent first. So negative 3 times a negative 3 is a positive 9. All right. Make sure you remember that this does not equal that. Okay. This is a negative 1 times 3 squared. And that doesn't equal negative 3 times a negative 3 is a positive 9. Whereas this is going to be a negative 1 over 9, which is negative 9. That's why that doesn't equal that. Okay, so make sure you remember that part. Sorry, this was a 46. This one here, so this is a 4 times 9 again, plus 4 times a negative 3. I need to do that next. You don't have to put in parentheses, but that just sort of reminds me. So this here and this here, 36 minus 12 of positive 4 times a negative 3 is a negative 12. You can leave it in the parentheses or just put it out like that. So when you're adding, subtracting, you have 36 minus 12 minus 2. That's going to be a 22. All right, so absolute value bars are in there, but then there's our inner parenthesis that you can do right there. That's the first move. So 7 minus 4 times 2. Stay within the parentheses. So in this case, the absolute value bars are next. Multiplication, 7 minus 8. Yes, it makes a difference. You cannot do 7 minus 4 and then multiply by 2. It's not the same thing. You have to multiply before you touch this negative sign here. And then the absolute value of 7 minus, that's going to be negative 1 inside absolute value bars, which is equal to a positive 1. So this whole thing is going to be a positive 1. I'm running out of room here. So this is going to be 14 minus 1. All that's taken care of. All that equals the 1, and then minus 10. So that comes out to a 3. All right. All right. So the other thing we wanted to warm up on is remembering how to plot a point from an ordered pair. All ordered pairs have the x first and then the y with a comma between them. To plot a point, you want to find the value of the x coordinate first on the x-axis. So where are my axes? That's the y, that's the x. So my first point here, that's the x, that's the y. So you need to find a positive 2. There's a positive 2 right there. You want to kind of pause at that positive 2. Don't put a dot. I'm just putting one for because you can't see where my pencil is. Go over to the 2 on the x-axis. Let me put a little dashed line here. Okay, I'm here. And then I want to go up to a positive 4. That's where your dot goes. Okay, right there is 2, 4. So you always go left or right first to find the x-axis. That's a 0, by the way. So left or right or on the 0, whichever. And then find your x first. And then from there, go up or down to your y. So the next one, where is negative 4? Negative 4 is over here. Pause there for a second, and then the y is a positive 4, which means we go up from there to a 4. So that's negative 4, 4. Okay? And then 2, 3. So positive 2, negative 3 is right there. All right? And negative 3, negative 3. Okay, that's how you put the dots on the line. So for Explore here, it says students will be able to identify functions and use the correct notation to evaluate functions at numerical and variable values. That's kind of wordy. Let's look at the skill 1 here. Identify if an ordered pair or graph represents a function. So you could get an ordered pair, a set of ordered pairs, a bunch of ordered pairs in a row. and you're going to be asked, is this a function, yes or no? Okay, if it is a function, it has a domain and range of that function. How far do the x's go up or down? How far do the y's go up or down values? Okay, so a relation is a set of ordered pairs. A function is a special type of relation in which every input has exactly one output. In other words, every x only has one y. Think of an input-output machine. If you put a 2 into the machine and you get out a 4, and we're talking machine as in an equation, okay? That means if you put a 2 in again, you want to get a 4 out. There should be no circumstances that you put a 2 in and you get another different answer out. This is not a function. These are functions. Okay? So every x only has one y. Okay? Another way to say that is no two ordered pairs have the same first with a different second. Okay? So if you're looking at a list of ordered pairs, you have a 2 is a 4, and a 3 is a 2, and a 1 is a whatever. Okay? So they have different x's. If you have a repeat x, if 1 is 5, then 1 on there again has to be 5 for it to be a function. If 1 is another number, then this is not a function. Okay? So you have to pay attention if there's any repeats in the x's. All right. If a line on a graph can only be intersected by a vertical line at one point, that's called the vertical line test, then it is a graph. So instead, if you don't get a bunch of ordered pairs and you get a line on a graph, let's say there's a line on a graph, okay? This line on this graph will pass the vertical line test because it can go straight through up and down and only hit it at one point, okay? If you have a graph and you have a line like that and you draw a vertical line, it'll hit it in 2 points. So that's not a function, that is a function, okay? If there is a function, then it has a domain and range. So this line right here was a function. This was a function. It has a domain and range. That means it has a list of numbers. It can also use infinity too. That has a low and a high number. The domain of the function is the set of all first coordinates, and most of the time it's an x. Okay, the first coordinates. Look at this right here. We have every time there's the other words for x. X is the first coordinate of an ordered pair. The x coordinate, the domain, the input, even the independent variable. If you put in this, you will get this out. Okay? So y can be the second coordinate, the y coordinate, the range, the output, or dependent. Your y is dependent on what is put in for x. Okay? So another way to say y equals something would say f of x. That means if this x here and this x here are the same thing. So instead of y equals, you could have function notation, which is an f and a variable in parentheses. Okay? Sometimes your x gets represented by an a, and your f could actually be a g, h, or k. There's a couple different things that these would be names of function. My function is f. That's like the name of the equation, or the expression that's function. Let me see if I can clean some of this off. We're going to be going through the details of this stuff. All right, that looks better already. Sorry for the scribbles. Let's say you have the function 2x plus 1, okay? Where do we get that? That's the same as this equation that is already solved for y. That means y is alone on one side. You can also call this the function notation of this equation, okay? This letter has to do with that letter there. Let's say g of a is negative 3a plus a. That's because the variable used here is an a, so we put it there, and then g is the name of that function. So if they say, okay, what if g G of A is 3. Hang on. G of A equals, what did I say? G of A through negative 3A plus A. And they'll say A is 4 or something. So G of 4 would be the same as negative 3 times 4 plus 4, right? So this letter right here represents every variable that's in the expression, okay? So that's function notation, but we'll do some more, I promise, of that. So let's look at the ordered pairs and determine if they represent a function, okay? If it is a function, you need to state the domain and range for these. So first thing we want to do is look through the ordered pair and see if there's any repeated x's, or all the x's are different. So there's a negative 3, a 0, a 1, and a 3. They're all different. So we don't have to be concerned that two x's have a different, or the same x has a different y. Okay. It's okay if some of the y's are the same. It doesn't really matter. Think of that input-output machine. If you put something in for x, what do you get out for y? It is possible to get two different things out. Two different things the same. I should not get ahead of myself. I apologize. Hang on. Let's just graph these ordered pairs right here. Sorry. Sometimes I get in a hurry and I don't mean to. Okay. So let's plot these. So where's negative 3? Go over to negative 3 and then an up 1. 0, 5, 0, 5, 1, 1, 3, 2. All right. Plotted the following below. Is that a function? Well, it passes the vertical line test because anywhere I put a vertical line, I only hit them once. And up here, there aren't any different x's, so that's a yes, that's a function. Okay, and then if it's a function, you're supposed to say the domain, put them in set notation. Now, think about that. The domain is all of the x's. So if you put them in numerical order, we've got a negative 3, a 0, a 1, and a 3 in set notation. That's all of the x's. That's the domain, right? The range is all of the y's. Remember, that's just another name for the y's. So the y's, if you look at that, there's a 1, a 5, another 1, and a 2. So 1, 2, 5. I know there's two 1s, but if you say that 1 is in the set, it's in the set. You don't have to write it twice, okay? We don't want to write it twice. We only want to write it one time because it's in the set. It's in the range, okay? And let's see. Let's go over to this one. All right, so just because these are in a different, order, the x is a 4, so go over to positive 4, and then down 2 for the y. And then there's 1, negative 1, 0, 0, and 4, 2. Well, this doesn't pass the vertical line test. And if the input is 4, you should get the same thing back out, and you don't. So this is not a function. Okay. How about this one down here? This is just a list in set notation. There's 1, 5. Let's see, all the x's are different, and that's good enough. So that's a function. All right, so the domain is what? 0 would be the first one, 1, and 8. It's just good practice to put them in order, especially if somebody has to check that you have them all. Negative 3, 4, and 5. That's the range of that function. Oh, I wrote it over there. How about this one? All the x's are different, so it's okay about the y's. So this is a function. And let's see, domain is 0, 3, 5, and the range is -2 to -1/8. Okay, and I'll put some more on the next video.